Okay, welcome to the Java OCA Unit 3 Lecture 1, titled Encapsulation and Variable Scope. In this lesson, we will discuss well-encapsulated classes, scope of a variable, and the life cycle of an object. So we start by addressing the question, what is encapsulation? Encapsulation is the process which binds the data and the methods of a class together. This is often referred to as information hiding. This is achieved by declaring your instance variables as private. By encapsulating instance variables, other classes do not have direct access to them. Therefore, you would need public methods called getter and setter methods to be able to retrieve or modify the state of each instance variable, or also what's known as what's stored by the instance variable. So one of the challenges of writing programs is learning to evaluate real-world situations and to represent them as objects and classes. So there are many real-world examples of well-encapsulated objects, such as an automobile, a cell phone, a wristwatch, public services, and so on and so forth. In this example, we are going to use a banquet hall as our well-encapsulated object. Well-encapsulated objects. Pause the video here, see if you can match up the real-world scenario with the corresponding Java components. Give it a try, and then when you're done, unpause and see how I did it. So I'm going to start by labeling my real-world scenarios as A, B, C, D, and E. And I'm going to take these letters, I'm going to put them next to the Java components I think they correspond to. So the first one, choice A, banquet service tasks. There's that word task. What do we use in programming to accomplish tasks for us? Well, hopefully you said methods. So I'm going to put A over here, that the banquet service tasks can be handled by Java methods. Banquet services as a whole, well, that's the whole thing, the banquet services, everything included. That would be my well-encapsulated object. That's everything all wrapped up together, the banquet services. Customer feedback. Well, we're going to get some feedback from the customers based on what they want in their party. Do they want a DJ? What types of foods do they want? How many hours? Do they want a cocktail hour? Do they want overtime? All of these different things. Customer feedback would be parameters that we're going to plug in so that we can give the customer a party that they enjoy. Schedule a new party. Well, as soon as you see that keyword new, that should be a dead giveaway. That's our constructor. And the total cost of a party, that's something that can be returned from a method. It'll calculate it and create an invoice and return the total cost of the party. So hopefully your answers match mine. If they don't, listen to what I said, how I described it, and link them. And this is the task of a programmer. You have to be able to take these abstract concepts and connect them to Java components. So the well-encapsulated object is a banquet service, and it has a class named party. The instance variables are private, and the customer feedback shows up as parameters. The scheduling of a new party is represented by a class constructor, and there are private methods that the public need not know about. They are the secrets of the business. And this is just a quick example of how I turn that banquet services into a class for scheduling a party, just so that we can see a concrete example of a program based on our well-encapsulated object. Next up, we want to talk about scopes of variables. The scope of a variable is determined by the braces from where it is originated. So these braces could belong to the class definition. These braces could belong to a method or a loop statement or a conditional statement. Some variables have a longer scope than others. The scope is also referred to as the lifespan of a variable, and the scope also defines where the variable is accessible. So if we look at this public class person on the right-hand side, we see that we have a brace for the class, and inside there we have some instance variables, name, and we have email, and these instance variables have full scope of this entire program. That means they are accessible in the purple, blue, and in the beige regions. If we look at the blue region, we have a parameter variable, length. Length is accessible in the blue and in the beige region. That's where it has scope. And if we look at the for loop, it defines a variable I, and I is a local variable to just that beige region. So sometimes we have to answer questions based on overlapping scopes. There are blocks in a program where many variables are accessible, and there are blocks where few variables are accessible. The accessibility of different variables is a function of the nested braces or the nested code blocks. So if we look at this question, which variables are accessible at line 10, we find line 10, and we say, which ones can we access here? We say, well, defined inside the pink region, we have the variable I, which is accessible. We have the variable x, which is accessible. We have the variable args, which is accessible. We have the variable max count, which is accessible. So let's click those off. And then we want to say, well, how about the variables a and b? And if we look, these are inside of different methods, and those belong to a different block. So those are not accessible at line 10. I have another question here. It says, which variables are accessible at line 14? So which variables can the static method called sum access? We would say, well, they have access to a and b, but do they have access to any other variables? And you should say max count. And those are all of the variables that have access at line 14. They have their own block of braces here, but they're inside the green block, so that means that max count is accessible inside the method sum. It's also accessible inside the method product. Another type of question you'll encounter on the OCA exam deals with scopes between classes. And here we have a question right away. It says, will the following classes compile and execute? And the answer here is yes. This is because of the way they are defined. Both classes belong to the same package, and both classes do not have an explicitly defined access modifier. This means that they will be declared as default access. Default access is also called package private, and package private gives access to classes in the same package. So if we look through here, we have skull is the package. Skull has the class eyes and it has the class brain that belongs to the package. Inside of the class eyes, there is a static variable called perceived. And inside of the brain class, we have an int variable called IQ. We have a constructor for the brain class, which initializes IQ. And then we have a main method down here. And the main method will print out eyes.perceive. So notice that's the class name, and that is the static class variable. So if you recall, static class variables are accessible even if a class object does not get instantiated. It's because of that keyword static. And then we initialize, we declare an eyes object E1 and we instantiate it. And then we have an eyes object E2 set to null. That means it's not storing a reference. This is just review. E1 stores a reference. E2 does not store a reference. Then it does system out print E1, and then system out print E1.perceived, and then system out print E2.perceived. And because perceived, again, is a static class variable, it is accessible up here at line 11 without an object of the I class, and it is accessible at line 15 and 16, where it is attached to an object of the I class. And when we print just the object E1, we get the class it belongs to, which is the fully qualified name, including the package skull.eyes, at, and then we have a reference value, which represents its location in memory. So everything worked fine here. And that's because up here, the class had no access modifier. It didn't say public, didn't say private. When we leave it out, it gets a default package, which is package private between all of the classes in that package. So we continue with scopes between classes, and the question, will the following classes compile and execute? And this time we see the answer is no. These classes belong to different packages. The brain class needs to import the heart class or use its fully qualified name, package and class name and all. So we see the heart class belongs to the torso, the brain class belongs to skull. These are different packages. They do not have package private access. So we're continuing with this discussion of scopes between classes. Now that the heart class was imported, will the brain class compile and execute? Again, the answer is no. The heart class is not designated as public. In fact, it has no access modifier, meaning that it's default access, or what we said was package private. And since they belong to different packages, it can't be package private. So what else do we have to do to make this work? Well, now we see that the heart class was imported and the heart class was set to public. So now that the heart class is imported and made public, will the brain class compile and execute? The answer is yes. And we see the output was generated here. All right, so just to recap all of this, we needed to either have the classes belong to the same package and have no access modifier, meaning they were default or package private, or if they belong to different classes and we do import them, the class must be public or else we can't implement the class. Next up is object lifecycle. Objects are born when you use that new keyword, that new operator. Once you use that, memory is reserved for the object's instance variables, and they are initialized and defined by the constructor. However, determining when an object becomes inaccessible could be tricky. Once an object is no longer referenced, then it becomes eligible for garbage collection. And the garbage collection is handled by the JVM's automatic memory management. So how is OCA going to question you on this? You have to keep track of when does an object no longer get referenced by a variable. Now, the Java garbage collector can be called using a command prompt such as system.gc. However, the JVM will not run it just because you call it. The JVM is better equipped to decide when the garbage collector should be called, and it usually ignores this command when you call it. The Java OCA exam will also ask questions to this effect, so simply ignore system.gc anytime you see it, because that's what the JVM will do. Instead, let's keep our focus on when an object is no longer referenced by a variable. So consider the object D1, which is instantiated on line 5. When will it be eligible for garbage collection? So we see D1 is instantiated on line 5. It is a new director, Ridley Scott, okay. And then D2 is a new director, Michael Bay. But then D2 is set equal to D1. That means that the reference or the memory location for D1 is now stored in D2. So both D2 and D1 store the same object reference for Ridley Scott. All right, D1 is printed, D2 is printed, they should print the same thing. Now D1 is set to null. Well, just because D1 is set to null doesn't mean the object has lost reference, because it's still being referenced by D2. Again, the question said, when will the object instantiated on line 5 be eligible for garbage collection? It's not eligible yet, just because it was set to null, because D2 is storing that reference. Now it calls the garbage collector. We need to just ignore this. Now D2 has a new keyword, and that new keyword assigns a new memory reference to D2. At this point here, at line 12, the object that was instantiated on line 5 is no longer referenced by a variable in the program, so our answer is D, line 12. This is the end of this lecture. So watch it again, take notes, do the skills checks, send me questions if you've got them.